question 2d, we have y is less than the absolute value of x minus 1 or minus 2. Again, we need to recognize what we're working with. We're working with an inequality, which is going to require us to use shading in our graph. Second thing we should be recognizing is that we have an absolute value graph, so that means it's going to be V-shaped. And then we've got to do some transformations on it. We've got two transformations that we have to perform. We have to slide it right one and up and down 2. Get that right. Okay, so what I want to do again is illustrate that all we're going to do is we're going to take our parent function, which is y equals the absolute value of x, and that absolute value of x in the previous video I showed you how to graph your x and y, so putting in -1, 0, 1, so that gives you 1, gives you 0, gives you 1 back. So graphing those points, 0, 0, 1, 1, -1, 1, the 2 would give you a 2, a -2 is a -2. But a -2 gives you a +2. So there's our parent function graph. That's if I would graph only the absolute value of x. We're going to use our transformations, what we learned about those. And if we want to work inside the grouping symbols first, because our order of operations requires us to do that. So if it's inside the grouping symbols, it was always a horizontal adjustment. This is going to be a horizontal shift, 1 unit to the right. It's always counterintuitive on horizontals. So when I see -1, it moves it right 1. If I see +1, it moves it left 1. And thus -2 is on the outside of the grouping symbol, so this is a vertical. And because it's subtraction, it's going to be shifting it down 2 units. So those are the two things I want to do to this graph. So the first thing I want to do is I want to be able to take my graph and slide it 1 unit to the left. If we do that, then every one of these points gets slid 1 unit to the, use a different color, 1 unit to the left. So this bottom goes 1 unit, set wrong again. It's -1. I always fight my own instincts. When it's -1, it has to go to the right one. This point gets slid over 1. This point gets slid over 1. This point gets slid over 1, and all those points. So now my graph just got moved 1 unit to the right. Then I want to go down 2 units, which means every point gets moved down 2 units. So 1, 2. This point goes here, down 2. This one will go here, and there, and down 1, 2, and down 1, 2. And that's the new path of my graph. I'll try to do that in a different color here. This is the final orientation of our changed graph. And now we want to interpret our inequality sign. Our inequality sign says it has to be less than, so I'm already readjusting what I drew there. Because it's less than, it needs to be a dashed line. So the dashed line is going through those points, indicating that we do not include the boundary line in our solution set. Then what we want to do is we want to test an ordered pair. I want to see is 0, 0 eligible. Yep, it's not on my finished graph, so I'm going to test the ordered pair 0, 0 and plug it into our original equation to see if that will be a true or false statement. So I'm coming back into our original. Is 0 less than or equal to the absolute value of, putting in 0 for x minus 1, absolute value minus 2. So is 0 smaller than, well, 0 minus 1 is a -1. The absolute value of a -1 minus 2, and I calculate the absolute value of a -1. The absolute value of a -1 is 1, and 1 minus 2 is -1. Is 0 less than a -1? Well, that is a false statement. 0 is not smaller than -1, which means we do not want to be on the inside of it, we want to be on the outside of it. So we'd be shading to the outside of our graph. So those are the transformations that we're using to graph absolute value inequalities. And then making sure that we dash the line when it's less than, and making sure that we shade the appropriate region.